it's my pleasure to introduce the next speaker, Saurabh. He's actually, I saw the talk, I was like, oh, that sounds pretty interesting. So I might actually join myself. So with that, I'll pass it on to you, and thank you. Appreciate it.
Thanks a lot. Hi everyone. Good afternoon. It's going to be a hard time to listen to such a dry topic right after lunch. So I'll make sure to make it a little more interesting. So just to get a little bit of a pulse of the room, is there anybody who actively develops mobile apps or works in mobile app security? Nice. So is it like Android or iOS? Nice. Cool. So I'm going to start the talk. So basically, the talk is divided into like 5 segments. First is the introductions, where I'll introduce myself, our team, and the kind of goals that we have with this talk. Then I'll try to scope the problem by explaining some of the common mobile app security flaws and how some best practices can be implemented and checked at a mobile app PR level. Then I'll show you how we do implementation of these checks using an open source tool called Danger. Then I'll talk about some of the outcomes and impact of doing such a thing in your organization, and come up with some like best practices of how exactly to make it more useful for your mobile engineers as well as the security team. So introductions, I'll first start with introducing myself. I've been working in the security space for more than 10 years. Currently, I'm working at Lime, where I was hired as a founding security engineer 3 years back. And I was responsible to bring a product security program from scratch at Lime. And we have reached a sufficient amount of maturity. Basically, I was hired as an engineer number 135. So you can see the amount of like the ratio, how exactly it is asymmetric. Like the first security engineer is hired at like basically at 135, so there is 135 to 1 kind of a ratio between security engineers and a software engineer at a company. So for my personal life, I like doing adventure sports. The image that you see there is at the top of Denali, which is the highest point in North America. And I like doing mountaineering, skiing, mountain biking, kite surfing, anything where I can go up a hill and come down. Going to our vision, we want to achieve compliance with industry standards and improve our overall security posture by building partnerships with engineering and non-engineering teams. This sounds very basic, but it's very hard to implement operationally. So we are striving and doing this and learning this every day as we go and mature our security posture. So we'll keep doing it and make sure to share our learnings with the industry. So some of the goals that we have for this talk, the first one is scalability of security reviews. So I just explained to you how asymmetric the ratio of security engineers to a software engineer is. So if you see like a tech stack for our company, it goes on from a mobile application to a scooter's firmware. And if there's only a single security engineer, it's a hard task to review everything that is going into production. So to scale this kind of a security review at a mobile app repository level and automating it provides a huge upside for us by providing certain guardrails for the developers. And the default behavior is the most secure one. The second one is preemptive vulnerability mitigation. I would say this is just a fancier term to say that the security best practices or the anomalies should not reach production. And before reaching production, we kind of mitigate them. So it's not really mitigation because as you move forward in the software development lifecycle, the remediation time increases exponentially. So the best way to remediate a security vulnerability is not allowing it to reach production. Then third one is shifting left automation. So the left that I'm saying is in the software development lifecycle, where left is the initial stages in the software development lifecycle and towards the right is the more later stages. So we would like to provide these kind of checks as left as possible. Fourth one is some real-time security feedback. So what we have seen is 80% of the times, if you tell people what the right thing to do is, they usually do it. And we kind of trust the developers as well as the person who's reviewing our code to make sure to do the right thing. And we are just providing them a way to identify these at a PR level, and we just trust them to do the right thing. Moving on to the scoping of the problem, I'll talk about some of the common mobile app security flaws. Basically, I've divided them into 4 different buckets. This classification is something that I've come up with. It's not like some standard. So first one is system API usage. By system, I am talking about the native iOS and Android system. They natively provide certain libraries and best practices that can be leveraged. So I'll talk about some of these flaws and how they can be prevented using best practices using these native frameworks. Data handling is basically every mobile app has certain data that it stores locally, and the way it saves on your local device, it should make sure that only your app is able to access it and able to write to it. So that comes under data handling. Data transportation would be the transportation of data between a mobile server and the backend server. So we have to secure this transmission channel as well. Fourth category is app hardening. So if you guys are aware of a standard developed in OWASP called MAS-VS, so the rate, it's the +R rating that you see, which is for resiliency. So to implement these kind of resiliency best practices, we perform some app hardening related best practices. So I'll jump into the app flaws, start with the system API usage. So before starting, I would just like to explain the format in which the slide is presented. So you see certain terminologies listed in front of iOS and certain terminologies listed in front of Android. So more or less, these checks will be divided into 3 parts. First is to identify the files that actually have these best practices implemented. Second is the actual identification of the event in the mobile app repositories. And once you identify these events, you need to check them, whether they are implementing the best practice or not. So in these 3 layers of checks, I'm kind of providing you certain terminologies that you can use in both Android and iOS to check this in your mobile app repositories and what the best practice is. So starting with cryptography, it's not only in mobile apps, but everywhere. You should be using the native cryptographic libraries or the most cryptography libraries that are used by the entire industry instead of developing your own. So iOS provides these in terms of, in like the library called CryptoKit. So you just try to check the presence of CryptoKit if it's being used. If it's not being used, then you basically fail the check and and you know that basically a custom cryptography algorithm is being used. And in Android, there is an event or a function called cipher.getInstance. And when you see this event, you know there is certain encryption or cryptography being used. And if it is not followed by Android key store system checks, then basically it's safe to assume that the native cryptographic libraries are not being used for Android. Moving on to the next one, it's app backgrounding. So you might be aware of this app backgrounding concept in like financial apps, where if you try to background your financial app, it basically resets the session. It does not saves the session anywhere. So the best practice is to clear and mask sensitive UI data when the app enters the background states or when the activities are paused. So to do this in iOS, basically sensitive data on screen will be hidden in the application did enter background setting. And when this setting, you find the setting in your PR, you need to check whether sensitive data visible on screen is hidden. This configuration variable, if it's true, that means that the application implements the best practice. If not, then basically your sensitive data is not being hidden. For Android, you check the event of on pause and on stop events, and then subsequently, if you find these events, then you check if the sensitive UI data is marked as sensitive. So to mark it sensitive and to check whether if it's implemented in the implementation, you check for certain keywords like mask sensitive data, clear sensitive data, hide content, and flag secure. So these are the natively available events that needs to be set true. If not, then basically your app backgrounding is not clearing the sensitive data on backgrounding. Second one is clipboard handling. This is again something you might have seen in financial apps where if you copy certain things in the application, you cannot paste it anywhere in Notes or in any other apps. So this best practice can also be checked natively in iOS. So basically you find these events in a file called as appdelegate.swift file. So if this file is found in the diff, uh, you know that you can check whether the user activities have persisted or not, and if it's being cleared on backgrounding. So UI pasteboard name find and UI pasteboard name general, these are the two events that you check to see whether it's being persisted or not being persisted. In Android, there's no such dedicated file name that you can check in the diff, but you can check for all the .kt files if you're using Kotlin, or .java if you're using Java files. And you see the instances of clipboard manager being called. And once this is called, you need to, if you see this instance, you find a clear primary clip, or you have to set the clipboard to be empty. If these two things are not being done, then the best practice is not implemented in your mobile app. Moving on to the next one, is autocorrection. This is, again, like, I can say that this is again a financial app thing where the autocorrection or autofilling of sensitive fields is disabled. So in iOS, you check for diff if the file viewcontroller.swift is being modified or not. And to check for the text field configuration, you see that if a text field is secure text entry set to a particular set field, then you need to check that the text field autocorrection type is no. So if it's set to no, that means that your sensitive text fields will not be autocorrecting them on the mobile app. And for Android, it's a little different. These files are .xml layout files, which are commonly used for defining edit text fields. And you need to find all these edit text declarations in the diff. And if any sensitive keyword appears in the edit text declarations, then you need to check the instances of text no suggestions, or you need to find that the text visible password is not set, which shows you that the password is not going to be visible in your mobile app. So moving on to the second category, which is data handling. We start with protection levels. So there are certain ways where you can set a protection level in Android and iOS. So to do this, you check the write function and write to URL function. If these functions are changed in the Swift files, then you check whether they call the complete file protection variable or not. If this is not set, then you kind of check NS data writing options. This is another way that you set protection levels in iOS. So if these things are not set in your mobile app PRs, then it's safe to assume that the best practice is not implemented. In Android, it's a little different. You basically check for get shared preferences usages, and if you find get shared preferences usages, you check for corresponding encrypted shared preferences, or if you implement a custom encryption or a cipher algorithm, depending on the context of your organization, you check that being called. If they're not being called, that means that the protection level is not set in your application. Second best practice would be data at rest. So every mobile app kind of saves some data in their local databases. So you need to make sure that the databases are encrypted. And you also need to make sure that the sensitive files that are stored locally on the device, they are set with correct permissions so that only your app is able to read and write to those files. So in iOS, this is done using core data or Realm Store, either one of them, which stores databases as .db files. So you look for XC data model directories, and for each directory, You check for contents for keywords like encrypt or, or any of the custom text that you call in your own mobile app. You check for those occurrences. If those are not implemented, that means your data is not encrypted locally. For Android, similar to that, it is using Room or SQLite. So you check for these keywords, and if the subsequent keywords do not follow with encryption or SQL cipher occurrences, that means that the local databases in Android is not implemented. And to check for file permissions in Android, you basically look for occurrences of open file output, which is commonly used method for writing files in Android. And if you find this occurrence without a mode private, which restricts file access to the app only, that means that the file permissions are not set appropriately, which can cause other apps to read and write to the local files saved by the application. Sensitive data storage. Uh, this is natively both the application frameworks provide ways to store native sensitive data securely. So in iOS, you should not use user defaults for storing sensitive data like access tokens or subscription flags and account information. You should use keychain service API instead. And for Android, you need to search for like hard-coded values of keys, tokens, and secrets being modified in your PR. And if you find these occurrences without the calling of Android key store or system.getenv or build config, then basically you're not using the native secure data storage mechanisms that is available in the framework. Cool. Moving on to the third one, data transportation. Uh, this is generic, and this requires a lot of checks that needs to be implemented. So there are 4 ways to ensure that the data in transit is secured by best practices. First one is to see whether the TLS version is above 1.2. Second one is to see whether there's no occurrences of HTTP being used and only HTTPS is being used. Then natively in Android and iOS, you have certain network security configurations that needs to be enabled. And if they're not enabled, that means that your app is not using the native functionalities that are available for securing a network security data. In iOS, you basically check for URL, and you see whether sensitive parameters are passed in, sensitive like text fields are passed in as parameters or headers. The right way to do it is to pass it in headers and not in parameters. And second check is basically to see HTTP usage. And if you see HTTP usage, you have to fail the check and ask the developers to use HTTPS. Then for native network security configurations, iOS has NS allows arbitrary loads, which completely disables the network security protections. And if you find NS exception domains, if they're added, that also weakens the network security configuration. So you need to check these two. If they are implemented, that means that you're not implementing the native network security capabilities that are available in iOS. Again, in Android, the first 2 checks will stay the same, checking for HTTP and checking for URLs not containing sensitive information being passed into parameters. The network security configuration for Android is maintained in a file called Android manifest.xml. And the configuration variable that you are seeing seeing on the screen as well is Android uses clear text traffic. So if this is set to true, then that means that the network security is not enabled in your application. You can add another check to see whether this security configuration file is even existing or not. And if it's not existing, that basically it means that you don't even use that configuration in the first place. So that is again a check that can fail and let you know that data in transit is not following the best practices. So moving on to cache. Cache can be applied very holistically, but what the best practices I'm talking about here is only related to the mobile application layer. and not the entire app, but only for the mobile application. We need to avoid caching sensitive information, and if you have to cache them, then it has to be managed securely. So natively, iOS and Android both provide certain ways to do that. In iOS, you have this setting called as URL cache, and if it's disabled, that means nothing is being cached, which is also good. But if you see that something is being cached, then you need to check that NSURL session contains words like sensitive and private, and if these kind of text fields are being cached, then you need to fail the check. In Android, you are checking for HTTP network calls where caching is explicitly disabled or securely managed. So you do that by using set use caches to false for HTTP URL connection, and OK HTTP client with no cache. This is another configuration way to check whether the caching is enabled or not. So moving on to app hardening. So this code obfuscation is again something that prevents anybody to reverse engineer your mobile applications. So natively, there are two tools. ProGuard is used for Android, and Swift Shield is used for iOS. In iOS, there is not a very sophisticated way to check this if it's being implemented or not. So you basically just check for keywords like obfuscate, scramble, and Swift Shield. And if you don't see those being implemented, that means that there's no code obfuscation being going on in your app. And in Android, it's a little more like defined, where the file that you're checking is build.gradle, and if in this file you see the release build type block, and in this release build type block, if the setting called minify enabled, if it's set to true, that means that the ProGuard R8 is enabled and it's performing code obfuscation. Another way to check is the existence of ProGuard files. That's also a way to understand whether ProGuard is being used or not in your application. Jailbreak detection. This, I think everybody is aware, like the cons of jailbreaking your device. The way to check them in this scenario is to find keywords like can open URL and is jailbroken. In iOS, if you find these, then that means that your application is detecting jailbreak devices. And in Android, there are multiple ways to do that, and to check it, you can look for keywords like is rooted, which is a common flag and method to check if the device is rooted or not. Then check for root, which is an alternative method name for the same thing. Is emulator, which is a common flag and method to check if the device is an emulator or not. Detect emulator, which is again an alternative method name to check the same thing of presence of an emulator. Build fingerprint in some checks identifies emulator patterns, and ro.debuggable is a system property check that can often be used in root detection. So the goal is to have at least one of them in your environment, and this shows you that your application detects jailbreaks. Debug logs is again like something which is consistent to the entire industry, not just mobile apps. So both the application frameworks, iOS and Android, provide their native logging frameworks, and it is always recommended to use them instead of using prints. And no sensitive information should be logged using these debug prints. So in Android, in iOS, you're checking print and log functions, which is used for debug printing. So, and in Android, you're checking for log.d and systemout.println. So if you see these occurrences, that means there is some debug logging enabled in your applications, which is certainly not a best practice, and this is something that should not be in production. So moving on to the next one, implementation with danger. So danger is like a pretty weird name, and also I was just talking about how exactly I basically fell on this kind of a tool. So initially in our security detection pipeline, we have a check to see if anybody is trying to bypass a status check in a GitHub PR. So we found this detection event in our pipeline where a mobile engineer was trying to bypass a check which was named danger. So we just reached out to him and said like, you're bypassing a check which is called danger, and this seems pretty dangerous. So so what exactly is happening? So basically they told us that they use danger for certain PR related like common chores which they want to remove from a manual review, like adding change log, adding a certain level of comprehensiveness in your GitHub PR descriptions. Uh, so this, and it was used for common linting process and not for any security related checks. So that put me in this like rabbit hole of identifying if this tool can be used for identifying these kind of best practices, since like both the platforms iOS and Android provide a lot of native capabilities to implement them, but if you can check them automatically if they're being used or not in your environment, that would be a huge plus for the security team so that they don't have to be involved in manual code reviews of all the PRs that are going into production. So to implement this, this is an actual check on a PR. So we basically use Circle CI, and danger is available in JavaScript. It's available in Ruby. It's available in Swift. We personally prefer Ruby because Ruby is the most mature one in danger. And we basically show the result using Fastlane because other static analysis tools results are also in Fastlane, so we just collate all of them in Fastlane and show it on a PR. So the thing to notice here is there are two different kinds of checks. First one is an error. So an error is basically something that will fail the PR and not go, the PR will not go to production if it's a required check in your GitHub repository. Warning is basically just showing you a PR comment. So in these scenarios, we are just expecting the developers and the code reviewers to do the right thing. We don't want to block the build in those cases. And in the next slides, I would present some use cases of when would you like to use a fail versus a warn scenario to have these two different kinds of outcomes that on a PR. So this is what a check looks like. The structure more or less remains the same in, I would say, 90% of the test cases that I just exhibited. So on a high level, what you're trying to do is when you see a diff or a GitHub PR, what's happening is first, if you are aware of which file to check, you basically check the file name in the Git diff. If you find that file name, what you are checking is the actual event. So here the event is text field is secure text entry. So this tells you that a text field in your mobile app is categorized as secure. So once you find this, you kind of check whether autocorrection is enabled or not for that text field. So that's the third check that you see, a text field dot autocorrection type is equal to no. So if this is not found, then you basically fail the test case saying that the autocorrection type is not disabled for a text field. There is another failure which shows that none of your text fields are marked as secure, which I find a little hard to grasp unless it's like an app where there's no login, there's only like showing information. There's definitely a scope of some secure text fields. So this is a multi-layer check which checks a secure text field and checks whether autocorrection is enabled or not. So whatever I was saying in the presentation in the slides before, I'm trying to detect events to check certain scenarios, and once I detect the event, I'm checking whether the best practice is enabled or not through configuration variables. Coming to outcomes and impact, which is why we are doing all this. So the metrics that change after this implementation, we are seeing a reduction in security flaws flagged during code reviews by 30%. And why we are seeing that is because we have some guidelines and we are promoting the use of best practices. So once you have these best practices enabled, automatically the security-related anomalies drop down. So this is something that we are seeing, and it dropped to like 30%, or it dropped by 30%. Then we are seeing some increased developer awareness of secure coding best practices. So whatever we are seeing here, this is not something that we just are in a silo and then we just add this check in the CI. We are actually sitting with the mobile app developers of both Android and iOS, and the success in this is definitely dependent on a mobile app engineer, because they're much more aware of how exactly these best practices can be implemented in the context of the application. So we increase sort of developer awareness of these for these security best practices in both Android and iOS. And third is just we reduce the manual review workload for a security engineer. We are always fighting uphill battle. The work is always asymmetric. So if we can get any help from an automation, that really helps us to focus on more high impact issues. So impact of automation, this actually promotes a shared responsibility model of security, where the application owners also feel that they own the security of their application. And once they understand what the best practices are, they are more inclined to help us out, and they basically point us to other applications where this danger file could have been useful, and they can add that also there. It streamlines the workflows by providing more contextual and real-time feedback during PR reviews. I always say that like trust is very hard for security, and it's very easy to lose just by one breach. So providing some real-time feedback is definitely helpful for both our teams and the mobile application teams. So best practices, I would say, in terms of implementation of this entire work stream. So certain recommendations that I have is automation. You can extend danger with custom scripts tailored to your organization needs. So I've talked about a lot of keywords that are very generic, but you can do a grep in your repository and see what exactly are the function calls that you use for those functions, and add those function calls as keywords in the test file. So basically customizing according to your organization needs is number one. Education, conducting specific education training sessions for developers on secure coding principles. So a lot of these best practices fall out of scope of just being solved in a PR. Some of them can be solved in a PR, which should be, and those kind of cases should fail the build. And if it takes a longer time to implement a secure best practices, then the best way to do that is adding that particular implementation as a backlog, where the mobile application engineers can spend more time researching the best way to do it, and then work backwards from there. Third one is standardization. Try to map these to your organization's coding standards for secure storage, data transport, and cryptography. Best way to get some buy-in is to see the security policies that a company have and try to map them to those, and say that you're operationalizing security policies for the mobile app environment as well. Last one is continuous improvement. It's not something static. It keeps changing. Natively, iOS and Android keep changing. If there are better ways to do the same best practice, make sure to make the changes in danger file, so that the mobile application developers are also aware of the best practices as they improve. Then release timeline. I would say this is one of the most important and make or break if you want to implement something like this. So the first step is to add these checks in the CI environment based on your understanding. And then you sit with the mobile engineers to fine tune those rules, so that if one of these danger checks exists and it fails for every PR, that means you know that it's not the right thing to do. If a check fails on every PR, then basically it should be turned off and make it transition to a warn case which does not block a PR. So always try to understand a fail versus warn, and in which use cases a fail would be beneficial versus a warn. So in security best practice, there are only two scenarios. One is your mobile app actually implements a security best practice. In those cases, what you're trying to save is a regression, where the security best practice is not removed from the application. In those cases, definitely fail works the best, because if it's removed, then you should just fail the PR and not let the code go to production. Uh, and the second case is when the security best practice does not exist in your environment. Then you need to sit with the mobile app developers and decide whether this is something that can be solved in a single PR, whether this is going to take some more time or long-term effort from their side. So in those cases, you just switch the cases to warn, where you just see a comment on your PR, but no, don't block it. So definitely, fail versus warn is something that can be a make or break for implementing such a practice in your company. Second, the last one is education. Education in terms of the specific education that you want to impart to the developers to implement these best practices, and the kind of education that you want as like the warn cases, which you add to a PR as a comment, and you just let the developer and the code reviewer take a judgment. If they want to accept a risk, they can go ahead and merge it. If they don't, then they kind of work on it. And the last stage is public launch, where you actually launch them to production, and all the PRs are actually going through these checks in your environment. So we are at the end. So any questions? Yeah.
Yeah, I do have some questions. First of all, I don't understand when you said don't block the PR. Was it that just for a warn, or was it you don't block it, but you just give a warning that?
Yeah, yeah. So you have two ways to check whether whether your PR can be blocked or it's just a comment. So if you see this file, you see this line number 230 and 235 have this thing called fail. So if you fail them, then it has this kind of the four errors that you see. So when you have these errors, it fails the check. And if it's a required check, then it blocks the PR.
Okay, yeah. Okay, that brings up another question. I don't really know this standards thing you talked. First, I thought was related to configuration management, like the dev somehow or whoever just go out. What did you the word you used? Kind of bypass? Is that the word you used? Bypass something that once you implement the danger, is this is a script or a software, right?
This is software. This is open source software, and you maintain the checks in a danger file.
Right.
And
So can you
yeah.
explain this, how is that different than putting in the code? I guess in a code, you can put all those, things too, like security related things, but this is something that's separate software you use. Why would you use it versus explicitly defining this in a code?
So I'm incentivized to move this feedback to as left as possible. So instead of like seeing this vulnerability in production and actually exploiting them, I'm just putting them in the PR so that it does not go to production.
So it's earlier in the pipeline.
Yeah, early in the pipeline.
That one, that's why, okay. Huh? Like a check before you, for PR, okay. And then, I'm sorry, anybody else has a question? Because I have another one that's, okay. So I'm not I use a mobile phone, but I'm not a mobile developer. I don't understand, when you talk about encryption and risk, okay, so my question is, I always thought all my files are somewhere in the cloud. Are you talking about like local files?
Local files.
I store it. Now, do you guys store most of your file locally? I kind of like that.
It's application data, so you don't control that. You don't know like
We own that. So,
yeah.
okay, so it's the application data. So it's not everything in the cloud. It's my data. Okay. I just know the files and stuff I can store, but application data is because all my stuff is on the web. It's a web server. And what do you mean? iPhone.
There's certain things related to a session that, or
The session.
yeah, that gets stored. Yeah.
The session data. Now I get it. Okay, because I have a platform. Okay. So, question that you also mentioned, there's other third parties can access. So you have to block it, right? Because other
Yep.
parties are trying to. That's my concern because I don't want other
Yeah.
third party. Now, are they required to give you a prompt saying, are you allowing Google, or I'm just using Google as example, collecting my data, but they're supposed to have a pop-up saying,
So usually they just give you a prompt stating the privacy policy that an application adheres to, but they don't tell you that whether the file permissions that the application uses is set in such a way that it can be used by other apps or it cannot. So you don't get that prompt.
So your check is, what was the check you said you would disable allowing
Yeah, so it was part of the data at rest, data handling security. So in that particular, you're checking for file permissions in get open file output, and if you set the mode as private, then that means that you're setting up the permissions appropriately, so that it does not is not it's not available to be read or written by other applications.
Okay, thanks.
Yeah. Yes. Yeah, so I would say you should map to your data classification policy in your organization. You need, if the categories will depend on your organization's risk acceptance, like courage. And once you identify those, it's easier to map those in the text fields. So whatever text fields are being categorized in highly restricted or restricted, you can have a policy stating that if it's a part of my data classification policy to be as a highly restrictive or restrictive, then I'm going to mark this as a secure text field, which is cleared from clipboard, is cleared on backgrounding. And once I set those, I can set what exactly is the behavior I want from that data.
Yeah, so data tagging, that's
Yep.
important, right?
Yep.
You don't want to have AI use your sensitive data.
Yep. Yep. So that is again like something which is like based on the constraints that you have in your organization. So for us, it's a small company, and if something is free, then use it. Like it's yes, yes, yes. So if this kind of thing offers, if it's offered for free, I don't get any pushback from anybody. I can just start using it. So I would say this is like not very sophisticated. It's just a grep. So I don't know like if what kind of PR guide square. Yeah, anti-jailbreak, yes. So I would say the tool Danger is not built at line. It's an open source tool, and this form factor of using it in a security context is what we have developed. Yeah, yeah, we use OAS. Yeah. Oh, okay. So basically, I've just tried to map those OS cheat sheets of iOS and Android into these test cases and try to find natively what are available in iOS and Android, what kind of configuration I can check statically. And if this exists, then I'm pretty sure that it's being implemented. If not, then I just give that feedback to the developers. Thanks.
Just a quick question. I'm not familiar with OS, like with the recommend for mobile. So obfuscation is a recommendation?
It's not, so OWASP has like different categories. Like you can have this L1, L2, L0, and based on your risk appetite, and there's all those categories L1, L2, L2, L0, L1, L2 have like plus R also. Like plus R is a resiliency. So if you want resiliency, then these code obfuscation, jailbreak detection, like anti-reverse engineering, if it's suppose like a gaming app, so you don't want that to be reverse engineered. Yep. Yes. Yep. It will.
Who cares about performance? I care about security. No, just security
So yeah, definitely, we can talk about after after the talk as well. If you have any questions, we do plan to release this open source, like the danger file that we have. But since this is the first like open source repository in our company, so it's taking a little bit time. But I do plan to release a blog post as well as this repository of danger file. No. Yeah. Yeah. Definitely.
Cool. So if no more questions or